Hi, good evening, Dr. Amod. It's a pleasure having you here. So we have with us Dr. Amod Anandkumar from Harman International. Dr. Amod, would you like to throw some light in terms of, what are the most exciting things that's happening at the lab right now?
Yeah. So it's a pleasure to be here, Sunny, and to interact with you here. So Harman is a provider of both consumer electronics and automotive systems. So we basically make things like infotainment units and audio systems for cars, and we are also heavy in the consumer electronics space with our brands like JBL, where we make earbuds and speakers and headphones and a wide variety of audio equipment. So, given this kind of range of market and products that we can work on, then my group is involved in research, focusing heavily on both sort of the audio applications and the automotive space, with a particular focus on efficient deep learning based techniques that can go into each of these platforms.
So what do you think? Is deep learning essentially all the methods that really go into production these days in audio systems or in ADAS, are they all deep learning based, or there's still some scope for good old fashioned AI, the HMMs or the older models? Do they play a role, or it's more of a bygone era and the focus has shifted totally to end-to-end deep learning models as on date?
No, it's in practice. I mean, there is definitely a room for both. Depending upon the complexity of the solution and the feasibility of the a particular hardware that you're trying to fix the solution on, you will have to make a very careful choice between a traditional feature engineering plus an SVM or a random forest rather than an end-to-end deep learning model. In many applications, you might have very little compute, either on the platform itself or something that gets allocated to you, given all the other things that that platform has to do. And if the problem is simple enough and you need it to be, easily debuggable and explainable, classical ML techniques do the job very, very well. Deep learning comes into play more when the problem domain becomes much wider and you have a lot less constraints on the input space in some sense. And that's when deep learning literally the only way to solve the problem.
Sure, but I keep hearing this debate, that if there's ever a choice between a system that's working at a very high level accuracy, so hypothetically a system that's working at an accuracy of say 98% versus a system that's 90% accurate but is explainable, most of the times, the debate is that you will take a system that works well, and like explainability is nice to have, but generally no one really pays that trade-off. What your experience has been on this front? Like, do industry or do systems in production, if they work, that's not good enough? Do we really have to bother about explainability?
When I mean explainability, I don't mean like the technical research domain of explainable AI with specific things like SHAP line and that whole series of techniques, right? I mean it even in a more generic sense, because when I'm building this technology, how do I know it's ready for market? And we can say it is something's at a 90% or 98%. The first thing is my test set defined well enough? Is my problem formulated well enough that these numbers actually translate to behavior in the real world? Because if I have a very narrow test set that does not capture the complexity of the real world, a 90% or a 98% does not really matter. That's one side of the problem, right? So then the second typical problem that comes is this kind of a data drift or a model drift that you get when you move from this test set to the real world. And you go to these iterations of improving the model and trying to resolve those issues that you see in the field. And that is where then, as a developer of that system, are you able to get enough insights about that system to be able to fix it and improve it or not? Is the type of explainability that I'm looking for.
Okay.
In many cases, it's much harder to do on a deep learning model. And potentially significantly more expensive to then go collect that extra amount of data that fills that data hole in your training. That is reflected in the real world, as opposed to a more classical system where I can think of a few more cleverer rules or a significantly lesser amount of data that's needed to retrain and so on. So that's where the trade-off really comes, and both are very critical, both are very valuable.
Sure.
But as ML leaders, we have to make that choice relatively early in the process. Otherwise, you have again this potentially slightly lesser solution, but at a lower cost of development versus a significantly better performance solution, but with the risk of potentially very hard to resolve later.
Sure.
So that's kind of how the
Yeah.
trade-off ends up shaping.
Yeah, and of course, as you pointed out, right, that deep learning models have this problem of domain shift, and our test sets has to be, similar to what the real world is, and that it's normally hard to do that job. You always find edge cases and extra cases that models really don't work well on.
Yeah.
So in the recent past, we have been seeing this idea of continual learning, like CBPR has having its own workshop on continual learning, which has been like an active academic area in the last few years. But say in production, in industrial research, say you have trained a model that works on one test set, but now you have new cases where the system doesn't work and you collect more data. Would you collect everything and again train end to end, or do you play with these ideas of learning continually? Such ideas make it into production, or?
Yes. The key kind of backdrop or the requirement for all of this is to have a very well built out MLOps framework. Right? MLOps, I mean the whole operations of machine learning process. It's like the evolution of DevOps to go from just the continuous integration, continuous deployment type settings that we used to have in classical software engineering, but adapting those for machine learning applications. So MLOps gives you that monitoring ability that helps you understand is that model operating well in production or not. Once you have that, then you're able to then figure out is there a drift. And typically MLOps platforms also allow you to then go and update the model on the fly, or trigger a retraining run and things like that. And depending on the overall solution, it could be a web-based thing that then just sends an updated set of weights to the final solution, or it could even be triggering something on device. Each of these are kind of more specific to that product and kind of how that solution.
And on the edge, have you in production, like do transformer scale models now it's possible to deploy them on devices?
Yeah, I mean generally there has been good evolution of simplifying and compressing transformers also. So there definitely have been a lot of papers that show how you can run.
So is it true all deep models now are transformers in production, more or less?
No, that is definitely not the case. There is still a place for CNNs, there is a place for LSTMs. Okay. Because see, in industry, we are not so much concerned on what is the fanciest network, but what solves the problem and do we understand the best. Sure. We need to have equivalent set of techniques and a fully built out ecosystem for that to be able to then confidently pick up something like that and then directly start using to solve the specific problem. So most of the research is applied research in that sense, where we take fundamental improvements that are out there in literature, and then we then try to apply it to the problem we need to solve for our product, right? Sure. Then as long as we understand it well enough and it meets compute and memory budgets, we then use it. Otherwise, it's a significantly harder problem to solve. Yes. And
is privacy or ethics concern, or are there other issues as a researcher that you have to grapple with while deploying the solution?
Oh yes, absolutely. I mean, it's a central and in fact like the starting point for a lot of research activities that we do. Especially if it's something that involves human subjects or deals with personally identifiable information, you can't even get started with some of the ideas unless you get clearance for that it is not having any challenges in terms of ethics or morality or legality from privacy and data protection standpoint.
As to like, how do you find this balancing act, in terms of a lot of researchers wants to go out there and publish their work while, a lot of industry research labs actually want to build products. Is there a tussle between the two that you have to somehow manage?
I mean, again, that becomes sort of a strategic choice whether you want to publish or not, right? And it takes a certain amount of time and a certain type of work. Right? Academic publishing requires you to have a certain level of novelty compared to prior literature and an ability of reproducibility of some of that work and so on, right? Now, if it is something that's practically very useful but not very new, there is no incentive to try and publish. On the other hand, if you have something that's dramatically new and potentially very valuable, again, there is no real incentive to publish. Other than, of course, the culture being, in open science and things like that. So I tend to, at least in my work, fall more on the former, where we are trying to solve new problems using a lot of existing, literature and not doing foundational science, but really applying a lot of existing learnings to solve specific problems on the path from science to product.
There has been a recent shift, right? Like where the big tech industries have at least taken the strategic decision, at least some of them, that they want to do everything in the open. And I think general computer science community has been, like pretty big on doing things in the open source, the patenting and business in lot of big research labs. What's your take on it? Is that the right approach, or do
No,
you think
open source is great. I mean, there's absolutely no doubt about that, and democratizing a lot of these learnings and techniques and being able to share is great, especially because a lot of it is already built on something that was previously open source. Right? It's only fair that if you're taking something from the community, we also give back and we help it grow and make it better for everybody else. Right?
So something to reflect on. Also, if you're graduating today, is there something that you would have done differently compared to when you graduated a while back?
It's a very hard question to answer because in some sense you have to reflect and react to the world that we see evolving. One of the things that I still I think still remains common between then and now is critical thinking, problem solving, and the ability to self learn. That has not changed. That has to be kept on top of mind. Probably what's different now is the kind of tools that you use and how you use those tools is definitely different from when I graduated versus the amount of tools and access to them is so much more democratized now. So to some extent, that tool proficiency and familiarity becomes a related aspect of kind of graduating. Also, skilling up on tools. And I can understand why that is the case because tools are evolving so rapidly. You create a curriculum today for, and by the time if you actually realize it to the final year, the tool would have changed. So it is.
Also, I think sometimes in academics, we really don't think tooling is really an academics discipline to be taught per se, and that's mostly left to students to pick up themselves.
Exactly. And again, because of very similar reasons, right? Tools keep evolving, the principles don't. And learning principles is definitely more important than learning the tool.
That's true. So how would you advise like young graduate students who are doing their bachelor's or PhD, like what should they focus on to build such critical thinking skills, which are, that would stand the test of time, where the models would change, so probably the algorithms would change, but what would be the best investment for their time now?
Yeah, I think it's on solving end to end, and going through the problem from beginning to end. What I mean by that is typically today when AI student, people do, students do AI projects, right? You usually pick up a data set, whether it's an image map or something else. And then you spend a lot of time, modifying and improving the models. And then you test it against a benchmark that has already exists. And that's very, very critical for publication because that's how you actually show that you come up with a fundamentally new thing. The difference in industry though is that usually the centerpiece remains relatively constant. And most of the effort actually goes in very cleverly creating and curating datasets. So I would encourage students to actually think of a real problem that is end to end, that you can build and do on your own. Use your phone, use your webcam, or use other sources of data wherever you can find. It could be your own Twitter feed or your own personal data that comes from various sources, whether it's text or images or signals. And from there, then think of, okay, how do I build some simple AI application on top? It doesn't need to be the fanciest thing. And that builds that skill of end-to-end problem solving. Of, am I measuring the right thing? Is my metrics meaningful? And is the data that I have connected and ready to solve the problem that I'm trying to solve?
I think setting up the ML pipeline is probably much harder than the algorithm, which more or less remains static.
Yes.
What changes for every application is what benchmarks you use, how you set up your pipeline, what kind of data set you curate.
Yes.
There's still merit in students in academia still learning hidden Markov models and graphical models, or probably those are now past their prime and students can move on and look at what the current state of the art literature is.
Yeah. So I would say, what's critical is students should still be very familiar with the underlying math that goes into any of those techniques, right? Rather than the specifics of NHMM or things like that. So the kind of math, the linear algebra or Markovian decision processes, Bayesian mathematics, right, random processes. So those are fundamental and they are constant.
What was your reason? I think after undergrad, you directly went for your PhD at Lobog. What made you do that?
Yeah. So during my undergrad, I was privileged to go for an internship during the summer of my third year. And there I got exposed to doing real research in a lab, and it was a fascinating experience.
This was lab in India or
No,
outside?
it was in Cardiff University.
Cardiff, okay.
Yes, and so I really also enjoyed working with my mentor, who was Professor Jonathan Chambers, and he then moved to Loughborough University, so
Okay.
that's why I went to Loughborough University to pursue a PhD with him, because I feel, especially for PhD, the advisor and student fit is very, very critical. Not every student and advisor pairing is optimal, and that's what causes a lot of challenges in a PhD program. And I kind of had really been inspired by working with him, and that kind of was why I picked that specific group and that university. And fortunately, kind of like we worked very well together, and I was able to finish in just 3 years. And I was just 24 when I defended my thesis.
That's not something that you find very often,
Yeah.
But a few weeks of internship actually transitioned into 3 years of PhD.
Yes, yes. And I mean, the system there was flexible enough that I was able to get admitted without the master's degree. And so that kind of
I think India is now much more flexible as well.
Yes.
A lot of undergrads now have an option to directly join for PhD.
Yes, yes. So it was a direct admission, and that kind of helped accelerate the journey significantly.
And do you find it very different, like being at Cardiff or Lobog compared to the academic system in India back then?
Oh yeah, significantly, right? One of the big differences is that here there's still a heavy focus on coursework, even for research program. Whereas there, for a research program, it was very much left to the student. If you feel you need to take courses, you can just literally go and take whatever you want.
Okay.
If you are on a self-study path and you're going to learn everything on your own, that's also perfectly fine.
Okay.
There is no hard and fast requirement that there is this basket of courses that you have to complete because you've enrolled in the program.
Okay.
And that helped me a lot because I picked up an area called game theory right at the beginning of my PhD. And there was very little, if any, academic kind of curriculum that was in my university. I don't think there was a course that taught game theory, as I remember. So I literally had to go get the textbook, learn it on my own. And not having a heavy course load helped do that and quickly start that process. Whereas if I had 2 semesters full of very heavy course load, then I probably wouldn't have been able to learn on my own while doing course.
But it's scary as a student to venture into something, on your own and not knowing really what's on the other side of the tunnel,
Yeah. But again, that's ultimately the intent of the PhD process, right? And that's where the mentorship matters a lot. The advisor able to kind of guide you through that scary tunnel that you are walking in blind, and shepherding you out on the other side safely is what really is the crux of the PhD advisor's role. And I lucked out in that space.
So do you have some advice from Professor Chambers that you still remember after all these years?
I mean, very much that kind of focus on doing good research, and kind of like the outcomes will handle on their own. Right? You focus on solving, pick a research topic and continue to just chip at it, and it's okay even if you don't see outputs for a while. But in the end, everything suddenly coagulates. And
but all students have these anxiety issues, right? That they're not getting the publications out.
Yes, yes. And I mean, it's real. I had that too. And it's a part of PhD process. There is definitely kind of that emotional complexity that a PhD process brings out, because there are no guarantees for any work, and there is the whole uncertainty of publication process. And, there is, I mean, peer review is a noisy process.
Yes.
So, and we all know that the way to reduce noise is to average over longer iteration, and that's what ends up then extending, and we might have to submit more than once.
I've seen a lot of students get very, very demotivated, once they put in and they get bad reviews. A lot of students have this, this rejection syndrome that, probably I'm not good enough, probably I'm doing everything wrong, I should change the research area. Is there some advice there?
I mean, there is no general advice is what I would say. And, each student has to be very clear about where they are, and, are they in the right path or not? And, do they have do they see a way to kind of get past that? Because in some sense, an early exit is far better than a late exit.
Yeah.
If you do have to.
But a lot of students don't know, right? I think is this a good way to know, whether someone is cut out for research or not, or probably that's not the right question to ask.
I mean, the strong motivation is very, very critical,
Mhm.
right? And it could be driven from whatever motivating factor. But being very clear that I do want to do the PhD, I want the degree, and I'm going to kind of stick on. That will get tested, whether you have it or not. In every PhD process, you'll come at that question at least a few times.
So, what do you find more enjoyable, the academic flavor of research, or doing research in industry? You've experienced both of them.
Yeah. I mean, both are having their own exciting parts and the dull parts. So it's each one onto their own. And in some sense, I mean, you work with your feet, right? And I'm in an industrial lab, so I obviously enjoy that. For me, what I enjoy most about industry research is I find that the most interesting innovation happens at the constraints. And like the constraints are what pushes innovation, what pushes invention and research. I find that those constraints are a lot more explicit and usually well thought out in the industry, whereas in academia, it's harder to find such constraints because the connection to product is significantly looser. Right?
So I think the last question. So what do you have some big research goals or big research threads that you are really looking forward to at Harman?
I mean, generally, I'm very excited about AI that can really make the human life a lot better. One of the projects that I'm really excited about is one that we're working on, where we're trying to understand how human mental state can understanding of the human mental state can really help improve the whether it's the driving experience or whether it's experience in the rest of your life. So that's something that is quite interesting and exciting and
yeah, sure. Well, thank you so much, Dr. Amod, for spending this time, and it was really a pleasure having this interaction. Thank you so much.
It was my pleasure. Thanks a lot.